Welcome to this Unit 20. We talk about area. It's just 1 year ago that we started here teaching from home, and this video is already there, Unit 20 from last year, but there's nothing more boring than a video, a YouTube video from 1 year ago. So we have an area under the curve. This is something which we have seen a couple of times already. For example, we have the function, we have seen the function y is equal to x squared, and we have computed the area under the curve here. So that gave us then the integral, say, from 0 to 1 x squared dx. And we have x cubed third as an antiderivative, which we evaluate from 0 to 1, that's 1/3. We have also seen that sometimes the area can become negative if you are under the x-axis. For example, if we take y is equal to sinus x, and we look at this function, this is pi, this is 2 pi, and we integrate from 0 to 2 pi sinus x dx. You see that we actually have part of it above the curve, so this is above, and then we have part of it below, that's below, and so we see that that is actually 0. So we have a cosine x minus cosine x evaluated from 0 to 2 pi, that is equal to minus 1 minus minus 1, that's equal to 0. So in this case, there was a cancellation between this and this. If we wanted to find the signed area, so this is the assigned area. If we wanted to find the area of this between, say, if you would ask what is the area between the sine curve and the x-axis, between sine curve and x-axis, so if we wanted this, then we would have to just add this area and this area together. So we would just take 2 times the integral from 0 to pi sinus x dx, which is equal to 4. So this area is 2, and this area is also 2 if we count it positive. So that's the difference between, this is a signed area, meaning that everything below the curve is counted negative. This is just if you really want the area, then we have to make sure that we count this with a negative sign. We will look at examples. Another thing I should point out is if we have 2 functions, like for example we have the function x squared and x to the 4th, and we want to find the area between these two graphs. So if we draw that, so this is x squared, x to the 4th might look like this. So this is x to the 4th, and that's x squared. And we have the area here between, so from -1 to 1. And in this case, it's important to make a picture to see what is above and what is below. So we can think about this as the area below x squared, and then we take away the area under the x to the 4th. We take this away. So what we have is, and this is the written there down, what we have is then just the integral from -1 to 1. We take the upper function, which is x squared, and then we take the lower function, which is x to the 4th dx. So let me just write this down. So this is the upper function. And this is the lower function. And in this case, let's just compute that quickly. So we get x to the 3/3 minus x to the 5/5, evaluated from -1 to 1. This is 1/3 minus 1/5, the whole thing times 2. So this is 4/15. So in this case, we just make a picture. And things should be clear. in order to analyze this, it's good to make a picture. So what we see is we draw the graph of x cubed, which is here, maybe minus 1, 1, and then the x to the 1/3 is a function which is actually just flipped around the y, x equal to y. So this is just completely symmetric here. So this is this one. This was this one. The problem asks you to find the area, not the signed area. We have already done such propeller problems. If you integrate blindly from -1 to 1, so that's one of the problems also. You have to figure out where they intersect. So where is x to the 3 equal to x to the 1/3? And you see that it's either 0, 0, 1 or -1. So these are the intersection points of this. If you do it blindly, we just say maybe x to the 3 or x to the 1/3 minus x to the 3 dx. That is actually 0 because this is a signed area. That's careful. In this case, it's the x cubed which is above. So we could actually write it the integral from -1 to 1, and then we have the x cubed minus x to the 1/3 dx. And here it's the x to the 1/3 which is above, 0, and then the integral from 0 to 1, x to the 1/3 minus x cubed dx. That's one possibility, that you split it up. Another possibility is that it's just we say this is 2 times the integral from 0 to 1, x to the 1/3 minus x to the cubed dx by symmetry. Symmetry often allows you to make computations a little bit easier. And in this case, we have no problem to integrate this, right? This is the integral. And then x to the 1/3 gives the x to the 4/3 times 3/4. And this gives you x to the 4/4. And we evaluate this from 0 to 1. And when we take 0, we get 0. When we get 1, we get 3/4 minus 1/4. That's 1/2. So this is just equal to 1. So this area is just 1. Pretty cool. Let's just draw this. So that's the curve x equal to -1. That's the easiest one. Then we have 2x squared, x squared half. That's this. And finally, we have also the curve 8 over 2 plus 6. These are the important points here, but we see that it actually just goes from -1 to 2. So we have to integrate from -1 to 2. And the upper function is 8 over 2 plus 6. And the lower function is x squared half. So this is something I think we can integrate that. So 8 over 2 plus 6 we know. So that's the 8 times the log of 2 plus 6. That's this. And then we have minus x cubed 6. And we evaluate it from -1 to 2. And we can evaluate that. That's just 8 times log of 4 minus 8, 6. And then we take -1. When we take -1, we get 0 here. -1 here gives us a plus 1, 6. So this is minus, actually I can put that here. When you put an absolute value, it's not so clear what is happening. You have to think about it. It means that y is big, if y is positive, y is smaller than x squared. So that's this. But it can also be negative, to negative y. So it is something like that. So it's this area. This is y is equal to x squared, and this is y is equal to minus x squared. And so that equation here, that inequality, actually means we have this butterfly type region, and then we can just integrate. We can integrate from -1 to 1, and then we have x squared minus x squared, so 2x squared dx. So this is 2x cubed third, evaluate from -1 to 1, so that's 4 third. So we have a function from, and we are integrating it from 0 to pi, and the function is kind of a little bit hard to draw because it's a fractal over 2 times sinus, and then we have 4x plus 1 over 4, and then we have sinus 4 square x, so this is 16x, and then plus 1 over 8, and then we multiply here always with 4, 64x. 1 over 1 times sinus 1x, that's the first part here. So, but that's actually quite fun because we see we can just integrate each part separately. We can do this. So this one, when we integrate this is just minus cosine x, evaluated from 0 to pi, which is equal to 2. We have already computed this a couple of times, and what we have here, when we look at that, that's minus cosine 4x over 8 from 0 to pi. But if you look at that, cosine of 4 pi and cosine of 0 is the same thing. So that is actually 0. That is equal to 0, and also this is equal to 0, and everything else is equal to 0. So we actually can compute this area. This area is equal to 2. I'll show you here the picture of the Weierstrass function. And that's it for today. We see them tomorrow in class.